Hello, it's Keith here, and this is lesson 24 of the Suck Hunt series, and we're looking at the Sega Master System again today. We're going to be looking at the final part of the Master System code, and indeed the final part of any of the Suck Hunt code. This is the last version of the game. So let's embrace the suck one more time and have a look at the last part of the code. We're going to be looking at the title screen and the main game code this time, so over we go. Okay, so here we go. Here is the code as we've seen before. So we went over the introduction last time. This time we're going to be looking at the title screen and from there on. Now the title screen code is a little bit different on this system compared to some of the other ones due to lack of keys, especially in light gun mode. So it's very slightly different. Now here is the code that draws the title screen. I think we covered this last time, but we'll just go over it very quickly. So we're loading in the two tile maps that define the left and the right eye here. We're then transferring the tile pattern data to VRAM here, setting the 3D mode, and if necessary, we're playing the speech. So the speech is handled by Chibi Sound. We needed to turn our graphics to 2D because that will mess with the interrupts, and otherwise the 3D effect is done by the interrupts. And we called Chibi Wave, which was something we covered in the platform specific series. It's a simple sound driver that plays wave samples, in this case a speech sample. Okay, so here is the start of the main title screen loop. Now what we're doing here is we're reading the input. The routine is called read mouse, but it actually reads the cursor, so either the light gun or the joypad, depending on how the game is set up. We've got a timeout until the introduction is shown again, and then we've got our main loop. Now, on all of the systems we've had in the past a way to select the 3D mode. Now, on the Sega Master System, we're using the pause button. So if the pause button is pressed, we are toggling the palette, switching to a different palette. And if we need to disable the 3D, we are doing so, effectively setting both of the caches to show the same 3D image. So that converts it to a 2D image. Now, this pause button is set by the interrupt handler, the non-maskable interrupt handler, because when we press the pause button, it doesn't appear as any kind of joystick button. A call to memory address 66 occurs, the NMI, and we're just writing a 1 to that pause button flag there when the pause button is pressed. So that happens every time the pause button is pressed. It's not like a switch that's a press and release. So in this case, when we're reading the pause button and it's pressed, we need to zero it so that it is effectively released. From then on, we're reading in from joypad 2 and we're checking the down button. And if the down button is pressed, we're going to start the game in hard mode, which starts from level 128. Now, the final thing we're doing here is we're checking the fire button. And if the fire button is pressed, we're checking the light gun position. And if the light gun is pointing at the screen, then we assume there's a light gun enabled. And if we just pressed fire on a joypad and we can't see that light gun, we're assuming that the light gun is not working. So we're disabling the light gun here. Now here's the start of the game code. We are setting the level number either to 0 or 128 if we're in hard mode. We're setting the song for the main game loop. We're initializing the game variables here, and then we are initializing the level. Init level will set up all of the enemies, and then we are repainting the screen to set the initial drawing screen. We've got a special function here called SMS force redraw, and this is used for clearing the screen, and this is primarily whenever a bat dies. On most systems the graphics were done with XOR. The Master System can't do XOR, so what we're doing is when something significant's happened, like a bat's been killed, the background beneath that will need to be redrawn, but for simplicity we're just redrawing the entire screen. So that's what that force redraw does, and we've got it here. We're checking for the force redraw. If we need to do a redraw, we're doing a full repaint of the screen here, repainting all of the sprites here, and then we're clearing that flag. Now this is the start of our main loop. So what we're doing here is we're processing the input. Again, read mouse actually reads in the joypad or the light gun. It's just named like that to match the other systems. We're then updating the sound. The SFX is done by my little Chibi Sound program. And then we're checking that pause button again. If the pause button is pressed, then we are going to need to pause the game. So we're turning the music off, disabling the interrupt handler here for the music, and stopping the music and stopping the sound effect here. We've then got a short delay just to debounce the keyboard basically. We're clearing the pause button here, and then we're reading in from the joystick. and the joypad rather. And the reason for this is we need some configuration options. Now, one is for the joypad if we want to configure the movement speed of the cursor in joypad mode. So for that, we're using Fire 2. And if Fire 2 is pressed, then we are going to toggle the speed. The speed is an array of 2-byte speeds, so we're selecting one of those, we're shifting to the left to effectively double the offset, we're loading in the speed and we're writing it to cursor move speed, which is used whenever a joypad direction is pressed. It's the alteration of the cursor. Now, of course, that's not needed in light gun mode, but in light gun mode we still do need one configuration option, and so for this, if the fire button is pressed while the game is paused, we're toggling the stereoscopic depth, and this is the separation between the two objects, and that affects how extreme the 3D effect is. Greater effect is more 3D, it has more 3D depth, it's more impressive in my mind, but if you've got a big screen or if you're not so comfortable with it and the depth is too great, it's going to hurt. So you don't want it as you kind of want it as strong as you can, but you don't want it too strong, otherwise it's not going to be comfortable. So we've got that. And then what we've got here is at the end of the pause loop here, we're just checking for the pause. And if the pause hasn't been pressed again, releasing the pause, we're just continuing reading in those keys to reconfigure the game controls. And then what we've got here is the end of the pause loop here. We're clearing the pause, we're turning the music back on, we're just waiting a while, and then the main loop starts again. Now, the first thing in the main loop is the tick. The tick is a 16-bit number, and this is used to affect the updating of all of the game events. So certain sprites might work every 10th tick or every 5th tick or every tick, depending on how fast they move. So this is the control for the game's speed, and as the levels progress, things will respond to more ticks than they did before to make them faster. Here's our sprite loop. We've got our sprite data count and the pointer to our sprite array here. And what we're doing here is we're going through the entire array and we're drawing the sprites to the screen. Now, we're actually going through in reverse order in this case, and the reason for that is it works better with the prioritization. On the XOR systems, it didn't matter what order we drew the sprites because they'd always look the same anyway, but this system can't do XOR, so the order does make a difference. So we're doing them in reverse order, so the most important objects are drawn last. Now, what we're doing here is we are then checking the tick, and we're going to see if we are potentially using the chibi gun, which is a minigun. It's an automatic weapon. So we're checking here 1 in 15 ticks, and that's the rate of fire. We're then checking if the fire is held down, and then we're checking the currently selected gun. And if the gun is the chibi gun and the fire is held down and it's tick 16, then we're going to use the fire. So we're firing here a bullet, and that handles the automatic weapons. The manual fire weapons are done elsewhere. The semi-automatic weapons are done elsewhere. Okay, then what we're doing here is we're checking fire down 2. Now this will be fire button 2 on the joypad, or it will be set if the player shoots away from the screen. So you can reload by shooting away from the screen, as is common in a few games. And we're using the reload function in that case, and then we're clearing fire 2. The final thing we've got here is we're checking fire 1. If fire 1 is pressed, then we're firing a bullet. And finally, we're updating the cursor and we're repeating this loop again. So this is the entire main game loop. All of the collision detection, the end of the game and things is handled in the multi-platform code in that animate sprite IY function. So there's very little code here to see. Now, most of the difficulty of porting to the Sega Master System was because of we're using the patterns for the tiles to draw the graphics to the screen. There's not enough hardware sprites to do it, and we can't do an XOR. So that's why this game was a little bit of a challenge, but I've abstracted most of the functionality in the sprite routines so that the majority of the code here is the same as it was before. So there we go. As I always say, you can go to the website, download the source code. You can use the source code in any way you want, even commercially if you manage to do so. And you can also download the pre-compiled version of the game. Now, usually this is the point where I advertise my book, but I'm sick of doing it, so I'm going to let my Chibi assistant do the honors here. Here's a Chibi code, there we go. So you can get the book from Amazon. And of course, if you like what you saw today, please like and subscribe. I'm currently working on a simpler little game called Suck Shoot, which is a very basic cut down version of this game, which I'm currently doing on the 6809 systems, but I'm hoping to do on the 8086 and maybe a few others as well. So that's the sort of spiritual successor to this game. I couldn't port a complex game like this to so many systems, But as I say, more stuff will be coming, and I am also working on another game which will be more portable to other systems because I'm designing it from the ground up with new multi-platform tile map drawing routines so that it's easier to port a game to many systems. Anyway, hope you've enjoyed this today. Thanks for watching, and goodbye.